to the circle at the point, and few problems on it. A length of chord to the circle, okay, which is formulated by 2 root r square minus d square. And finally, length of chord when the circle makes intercept with the coordinate axis. If it makes x-intercept, then the length of chord is 2 root g square minus c, etc. Okay. In this session, we are going to discuss various problems to finding the length of chord formed by the circle, especially in exercise 1c, and finding the area of triangle formed by the normal line at the given point to the circle, and some miscellaneous problems. Okay. Here we are going to discuss one problem. Find the length of chord formed by x square plus y square is a square on the line x cos alpha plus y sin alpha is equals to p. Here, just observe the question. Here the circle equation is x square plus y square is equals to a square, and the line is x cos alpha plus y sin alpha is equals to p. Okay, just observe the circle, that is x square plus y square equals to a square. That means center of the circle is origin. Okay. Just observe this circle. It is in standard form of this circle. That is x square plus y square is equals to r square. Okay. When the circle is in standard form, we can say that center of the circle is origin, and radius is a, because r square is equal, instead of r square, a square is there. Therefore, radius is equals to a. Okay, and again, just observe this given line, that is of the form ax plus by plus, if you transpose p into LHS, it may change as minus p, which is equals to 0. Is of the form ax plus by plus c is equals to 0, which is the general form of line. Okay, as you know already, which we have discussed in last session, the length of chord formed by the circle on the line is 2 root r square minus d square. Is it clear? 2 root r square minus d square. Okay, where r is the radius of the circle, r is the radius of the circle, and d is a perpendicular distance from center to the line. Okay, or this is small d, and radius of the circle is r. Okay, just observe this picture. Here, the pink shaded region is represents circle equation, and the here this is the line which is x cos alpha plus y sin alpha is equals to p. Here, the length of chord means the length of line segment AB. We need to find the length of AB. Okay. Given that the circle equation is x square plus y square is equals to a square, which is of the form x square plus y square is equals to r square, as you know already, which is the standard form of the circle. Okay, here just when it is standard form, we can say that center of the circle is origin and the radius is equals to, okay. The given line is x cos alpha plus y sin alpha is equals to p, or just transpose p into LHS. Here I am writing cos alpha into x, because here cos alpha is constant, sin alpha is constant, p is constant. Therefore, some constant into variable x. Therefore, cos alpha into x, sin alpha into y. If you transpose p into LHS, it may change as minus p. Therefore, cos alpha into x plus sin alpha into y minus p is equals to 0. As you know already, is of the form ax plus by plus c equals to 0, which is called general form of equation of line. Okay, whereas A equals to cos alpha, B equals to sin alpha, C is equals to minus. Okay. We know already the length of chord is formulated as 2 root r square minus d square, which we have already discussed. Okay, 2 root r square minus d square, where r is the radius of the circle, but d is the perpendicular distance from center of the circle to the line L is equals to 0. Here, this is the radius r, and also it is also radius r. Here, small d means the perpendicular distance from center of the circle to the line L is equals to, this is small d. Okay, as you know already, a perpendicular distance from the point x1, y1 to the line ax plus by plus c equals to 0 is modulus of ax1 plus by1 plus c by root over a square plus b square. Okay, this is the formula for perpendicular distance. Okay, perpendicular distance from the point x1 and y1, x1 and y1 to the line ax plus by plus c is equals to 0. Okay, this is the perpendicular distance. Therefore, it is indicated as small. Therefore, d is equals to ax1 plus by1 plus c by root over a square plus b square. Whereas x1 is x1, y1 means center of the circle. Therefore, x1 is 0, y1 is 0. Okay, here a is cos alpha, b is sin alpha, and c is minus b. Therefore, a into x1 cos alpha into 0 plus b into y1, b means sin alpha into 0 plus c, that is minus b by root over cos alpha whole square or cos square alpha, cos alpha whole square or cos square alpha, and sin alpha whole square or sin square alpha. As you know already, a cos square alpha plus sin square alpha is 1 because it's a trigonometrical identity. Okay, cos square alpha plus sin square alpha or cos square theta plus sin square theta is 1. Therefore, here 0 into some cos alpha, that is 0, 0 into some sin alpha, that is 0, 0 plus 0, 0, 0 minus p, that is minus p by root over 1. Minus p by root over 1 is nothing but modulus of minus p. Here we are finding the perpendicular distance. Here the distance is either 0 or more than 0. Either 0 or more than 0, but not negative. Hence, we are taking modulus symbol. Here, modulus of minus p is p. Okay, for example, if you get the distance value is modulus of minus 3, you can write modulus of minus 3 as plus 3. Therefore, here the d is equals to p. D is equals to p. Therefore, the length of chord, as you know already, which is formulated by 2 into root over r square minus d square, where r is the center of the circle, radius of the circle, and d is the perpendicular distance from center of the circle to the line ax plus by plus c equals to 0. Just substitute r as a, that is a square, minus d square, that is p square. Therefore, the length of chord formed by the circle x square plus y square is equals to a square on the line x cos alpha plus y sin alpha is equals to p is 2 into root over a square minus p square. Okay, once again, I am recalling you. Here, we should find the length of chord formed by the circle with the line. Okay, as you know already, the length of chord is 2 root r square minus b square. Okay, where r is the center of the circle, sorry, R is the radius of the circle. R is the radius of the circle, and D is the perpendicular distance from center of the circle to the line. Okay, just observe the circle equation, which is of the standard form, that is x square plus y square is equals to r square. Instead of r square, a square is there, therefore radius is equals to a. When the circle is in standard form, the center of the circle is origin. Is it clear? Okay, here the center of the circle is origin, radius is a. And the given line is x cos alpha plus y sin alpha is equals to p. Okay, I'm writing cos alpha in front of x because here cos alpha is constant. Therefore, cos alpha into x plus sin alpha into y. Here, transposing p into LHS, that is minus p, which is equals to 0, is of the form ax plus by plus c is equals to 0. Here we have already found the radius of the circle. Now we are going to find the value, that is the perpendicular distance from the center of the circle to the line, which is represented by small d, or simply Cp. Here d is equal to, as you know already, perpendicular distance from a point to the line is ax1 plus by1 plus c by root over a square plus b square. Okay, just a means cos alpha into x1. X1 means center of the circle. That is here x1 is 0 and y1 is 1. Here x1 is called abscissa, y1 is called ordinate. Okay, just I am recalling you. Here first coordinate or x coordinate abscissa. Here y1 second coordinate or y coordinate or ordinate. Abscissa, ordinate. Here abscissa is 0, ordinate is 0. That is x1 is 0, y1 is 0. Here c is minus p by root over a square. A square means cos alpha whole square or cos square alpha plus b square, sin alpha whole square or sin square alpha. Here cos square alpha plus sin square alpha is 1 because it's a trigonometric identity. Here cos alpha whole square and sin alpha whole square. Okay, 0 into something, 0 into something. That is minus p by root over 1. Root 1 means 1. Modulus of minus p means plus p. Therefore, the length of chord is formulated as 2 root r square minus d square, as you know already, which we have discussed in our last few sessions. Okay, r is radius, that is a. Therefore, r square means a square, d square means p square, which is the length of chord to the given data. Okay, next one. Here we are going to equation of circle. Okay, find the equation of circle with the center 2, 3 and touching the line 3x minus 4y plus 1 equals to 0. Here, which is the required circle, we should find, which is s equals to 0 is a required circle. Okay, with the center C is 2, 3. C is 2, 3. Here C. Center of the circle is 2, 3. And touching the line 3x minus 4y plus 1 equals to 0. Okay, which is the circle which we need to find. Okay, there is in the question, center is given and the line is given. Okay, we have already find some concepts in previous session. When the circle touches, when the line touches the circle, okay, here suppose C is the center of the circle and P is point of contact to the circle, then CP is equals to R. CP is equals to R. Is it clear? CP is equals to R. Here the C is the center of the circle. 3x minus 4y plus 1 equals to 0 is a line which touches the given circle, which required circle. Okay. Given line is 3x minus 4y plus 1 equals to 0. Okay. Just observe this question. Center is given. Center is given. If you find the value of radius, you find the radius of the circle, you can find the equation of circle. Can you find the equation of circle? Or simply that is x minus h whole square plus y minus k whole square is equals to r square. Given line is 3x minus 4y plus 1 is equals to 0. And the center of the circle is given. Center of the circle is 2, 3 given. And also given that the line touches the circle, that means perpendicular distance from center of the circle to the line, that is CP. Okay, here I am assuming point of contact is P. Here the center of the circle is C, then CP is equals to R. Okay, therefore CP is equals to, as you know already, the distance from center of the circle to the point of contact is equals to R. Here the formula from a point to the here the formula is the distance from center of the circle to the line, that is ax1 plus by1 plus c by root over a square plus b square. Okay, here a is of the form ax plus by plus c, whereas a equals to 3. Okay, a equals to 3 and b is equals to minus 4 and c is equals to 1. Okay, x1 is 2, y1 is 3. Okay, substitute all these values. That is a into x1, 3 into 2. Okay, 3 into 2. And b into y1, minus 4 into 3. Plus c, that is 1, by root over a square, that is 3 square, b square, minus 4 whole square. 3 into 2, 6. 3 into 2, 6. 4 into minus 4 into 3, that is minus 12 plus 1. 6 plus 1, 7. 7 minus 12, that is minus 5. 3 square, 9. 4 square, 16. 16 plus 9, that is 25. Square root of 25 is nothing but 5. Minus 5 by 5, that is minus 1. Modulus of 1 is 1. Therefore, CP, the value of CP is 1. The value of CP is 1. As you know already, CP is equals to R also. Okay. From the question, according to the question, CP is equals to R. Okay, but we are finding the value of CP, that is 1. Therefore, CP is equals to R, which is equals to 1. Okay, already center of the circle is given, that is assumed as h comma q. Therefore, radius of the circle is 1, center of the circle is 2, 3. Now we can find the equation of circle. Okay, can we find the equation of circle? Yes, by using x minus h whole square plus y minus k whole square is equals to r square. As you know already, where h comma k is center of the circle, r is the radius of the circle. Okay, or just substitute h as 2, k as 3, r as 1. That is x minus 2 whole square plus y minus 3 whole square is equals to 1 square. Okay, after expansion, the equation of circle x square plus y square minus 2 into 2x, that is minus 4x, minus 2 into 3y, that is minus 6y. Here 2 square is 4, 3 square is 9, 4 plus 9, 13, 1 square means 1. Here if you transpose 1 into LHS, 13 minus 1 is 12. Okay, which is the required circle equation. Okay, just observe this circle equation, whether the center of the circle is verified or not. Here is of the form x square plus y square plus 2gx plus 2fy plus c, 2fy plus C equals to 0. Here 2G equals to minus 4 means G is equals to minus 2. Okay, 2F is equals to 3 means F is equals to minus 3. But center of the circle is minus Z comma minus F. That is minus of minus 2, minus of minus 3 is 3. Okay, in the question, center of the circle is given as 2 comma 3. In our answer also, after verifying, center of the circle is 2, 3. Hence, our circle equation is okay. Once again, I am recalling you. Find the equation of circle with the center 2 comma 3 and touching the line 3x minus 4y plus 1 is equals to 0. Just observe the question. You may get an idea. What are the steps which we are going to discuss? Here, the center of the circle is given. When you find the radius of the circle by using this data, you can find the equation of circle by directly by using x minus h whole square plus y minus k whole square is equals to r square, because center of the circle is already given. Just we need to find the radius of the circle. Okay, when you find the radius of the circle, you can find the equation of circle directly. Okay, here we are going to find the radius of the circle. Okay, already in the question, center of the circle is given 2, 3. And the line is 3x minus 4y plus 1 is equals to 0. And also given that the line touches the circle. The line touches the circle means the distance from center of the circle to the line. Okay, I'm taking this point of contact is some P. That is CP. Here the distance is CP. Okay, but also it is observed that it is also radius of the circle. Okay, hence when the line touches the circle, CP is equals to R. When the line is exterior to the circle, CP is greater than R. When the line intersects the circle at two different points, then CP is less than R. These concepts were discussed in a few sessions ago. Okay, here the line touches the circle, that means CP is equals to R. Okay. Center of the circle is given by R2, 3. Given that the line touches the circle, that means CP is equals to R. CP means the perpendicular distance from the center of the circle to the line, which is formulated as ax1 plus by1 plus c by root over a square plus b square. Whereas a is 3, b is minus 4, c is 1, and x1 is 2, y1 is 3. Okay, I just substitute all these values such are a, b, c, and x1, y1 in this formula. After simplification, you can get the value of CP is 1. CP is nothing but the perpendicular distance from center of the circle to the line, that is 1. Also we have discuss the length of this line segment is radius of the circle, that is CP is equals to R. Therefore CP is equals to R is equals to 1. Therefore radius of the circle is 1. Already in the question given that center of the circle is 2, 3. Okay, here our most of the solution is completed. Okay, our intention is of finding the radius of the circle. Okay, therefore now if we can solve this, we can find the equation of circle by using the formula x minus h whole square plus y minus k whole square is equals to r square. Just substitute h as 2, k as 3, and r as 1. After simplification, you can get the equation of circle as x square plus y square minus 4x minus 6y plus 12 equals to 0. You may check, you may cross check your answer by finding center of the circle. Okay, whether the center of the circle is 2, 3. Hence, our answer is correct. Okay. Now we are going to discuss one more problem. Find the equation of circle with the center minus 3, 4. And it touches the y-axis. Here the like actually in the previous question, it touches the line. Find the equation of circle with the center 2, 3, and it touching the line 3x minus 4y plus 1 is equals to 0. In this question, a center is given. It touches the line touches this circle. But in the present question, line is not given, but the required circle is touching the one of the coordinate axis, that is y-axis. Okay. These are the coordinate axis. A required circle, that is center of the circle is minus 3, 4, and which is touching the y-axis. Okay. Now we should find the equation of circle. In the same way, okay. In the previous session, in the back of 2 previous sessions, we have already studied when the circle touches the x-axis, then the condition is g square is equals to c. When it touches y-axis, f square is equals to c. Okay, here we have discussed in last session also. Here the length of chord when it touches x-axis is 2 root g square minus c. Is it clear? When it intersect x-axis at 2 different points, then the length of this line segment are simply x-intercept. Okay, the length of this chord is formulated as 2 root g square minus c. Okay, or when it intersects at 2 different points, but when it touches x-axis at only one point, then the condition is g square is equals to c, because when it touches, there is no x-intercept, there is no length, there is no chord. That means there is no length of chord. There is no length of chord means here the length of chord is 0. Here the length of chord is positive, but here there is no length of chord. There is no chord in this second case. There is no length. There is no chord means here the length of chord is 0. Just transpose 2 into RHS, that is 0, and squaring on both sides, that is g square minus c is equals to 0, which implies g square is equals to c. Okay, just I am recalling you. When the circle intersect the x-axis at 2 different points, the length of this chord is 2 root g square minus c. Okay, when the circle touches this x-axis, that means the length of this chord is 0. That implies g square minus c is equals to 0. That is g square is equals to c. Okay. Similarly, if the circle intersect the y-axis at 2 different points, then the length of this chord is 2 root f square minus c. 2 root f square minus c. Okay. Similarly, when it touches y-axis at only one point, then the length of this chord is 0 because there is no chord. That means if you transpose 2 into RHS, that is 0, squaring on both sides, that is f square minus c is equals to 0, which implies f square is equals to c. F square is equals to c. Okay, just when the circle touches the y-axis, when the circle touches the x-axis, then the condition is g square equals to c. When the circle touches the y-axis, then the condition is f square is equals to c. Okay. If it touches x-axis, then the condition is g square equals to c. When it touches y-axis, then the condition is f square equals to c. Okay. Just observe the question. Center of the circle is given, that is minus c comma minus f is given. Okay. Comparing these ordinates, that is g comma f, you may get the value of g and f. If you find the value of c, then you can find you can evaluate the equation of circle by using general form of the circle, that is x square plus y square plus 2gx plus 2fy plus c equals to 0. Okay, here the condition is given when it touches y-axis, that is f square equals to c. Okay, all these, by using all these concepts, now we are going to discuss the solution of this problem. Okay, center of the circle is given, that is minus 3 comma 4. Okay, when the center of the circle is given h comma k, we can assume that here minus 3 comma 4 as h comma k or minus 3 comma minus f. Okay, depend on situation of the solution. Okay, a requirement of assumption. Okay, now I am assuming the center of the circle is minus g comma minus f. That is minus g is equals to minus 3, which implies g is equals to 3. Is it clear? And minus f is equals to 4, which implies f is equals to minus 4. Okay. G is equals to 3 and f is equals to minus 4. Given that the circle touches y-axis. Okay, when the circle touches y-axis, we have already discussed, then the condition is f square is equals to c, which implies f square is equals to c. Okay, f square equals to c means c is equals to f square. Therefore, c is equals to f square. F means minus 4 whole square. Okay, minus 4 whole square means 16. Therefore, the value of c is 16. Okay, just observe these steps in this solution. G is given, that is 3. F is given, that is 4. We have already found the value of c is 16. Okay, now we can find the equation of circle. Okay, that is x square plus y square plus 2gx plus 2fy plus c is equals to 0. Okay, just substitute the values of g, f, c, that is x square plus y square plus 2 into g, that is 3. 2 into 3 into x, that is 6x. Okay, 2 into f into 2 into minus 4 into y, that is minus 8y. Therefore, required circle is x square plus y square plus 6x minus 8y plus c is equals to 0. Okay. Just once again, I'm recalling you. Here, the question, in the question, required circle touches the y-axis. Required circle touches the y-axis. That means when the circle touches the y-axis, condition is f square is equals to c. Okay, here the center of the circle is given as minus 3 comma 4. I am assuming center of the circle is minus 3 comma minus f. When you compare this abscissa and ordinate. Abscissa means x coordinate, ordinate means y coordinate. Okay, after comparing this abscissa and ordinate, g is equals to 3, f is equals to minus 4. As you know already, when the circle is touching y-axis, then the condition is f square is equals to c, or simply c is equals to f square. Therefore, c is equals to f square means minus 4 whole square, that is 16. Okay, here g and f are given in the question. We have already found the value of c. Therefore, you can find the equation of circle, that is x square plus y square plus 2gx plus 2fy plus c is equals to 0. Okay, just substitute value of g, that is 3, value of f, that is minus 4, the value of c, that is 16. After simplification, you can get the equation of circle is x square plus y square minus 6x plus 8y plus 16 equals to 0. Okay. This is one important note. Actually, this concept was covered in your previous academic year, that is 1B. The area of triangle formed by the line with the coordinate axis. With the coordinate axis means both x-axis and y-axis is half into modulus of c square by ab, or simply we can write modulus of c square by 2ab also. Okay, when the line ax plus by plus c equals to 0, okay, formed by a triangle here, yellow shaded region represents a triangle which makes by the both intercepts, sorry, both coordinate axes in a plane and the line L equals to 0. Okay, the area of triangle formed by a line ax plus by plus c equals to 0 with the coordinate axes such are both x and y axis. Here the triangle is formed by both x coordinates and y coordinates. Here the length of, or suppose the intersecting point of line and x axis is a, the intersecting point of line and y axis is p. Here the length of OA is called x-intercept. Okay, the length of OA is called x-intercept. The length of OB is called y-intercept. Okay, if suppose if you find the x-intercept, that is small a1, y-intercept is small b1, we can write the area of triangle is of mod AB. Okay, when you find directly both x-intercept and y-intercept, you can find the area of triangle by using delta is equals to half mod AB. There is no problem, both are same. Okay, once again I'm recalling you. The area of triangle, which were represented by yellow shaded region. The area of triangle formed by a line, that is ax plus by plus c equals to 0 with the coordinate axis, that is both x and y axis, is half into modulus of c square by ab, or sometimes you can write 2 is inside of this modulus, that is modulus of c square by 2ab. Okay, this is the concept which we have already discussed in straight lines chapter in your first year syllabus. Okay, now we are going to discuss one problem. Find the area of triangle formed by the normal line at 3 comma minus 4 to the circle S is equals to 0, where circle equation is x square plus y square minus 22x minus 4y plus 25 is equals to 0, which is the circle, and the point is given as P 3 comma minus 4. Okay, here the equation of normal, this is the equation of normal. Okay, here this is the equation of normal, which is equation of tangent. Is it clear? Because our tangent line touches the circle at only one point, that is P, and P is called also as a point of contact to the circle. P is called point of contact to the circle. Okay, here the line is called a tangent line, and this line is called normal line. Okay, as we know already, normal line is always passing through center of the circle. Okay, now we have find the value of, that is area of this triangle. This is the triangle. This is the triangle. We need to find area of this triangle. Okay, area of this triangle. Okay, just observe the given data. That is, a point is given as 3 comma minus 4. I am assuming x1 as 3, y1 as minus 4. Okay, and the given circle is x square plus y square minus 22x minus 4y plus 25 is equals to 0. Okay, or just compare this given circle equation with the general form of circle, that is x square plus y square plus 2gx plus 2fy, 2gx plus 2fy plus c is equals to 0, where 2g is minus 22, that implies g is equals to minus 11, and 2f is equals to minus 4. 2f is equals to minus 4, that is f equals to minus 2 and c is equals to 20. Okay, I'm recalling these three steps. Given point is 3 comma minus 4, there is no problem, but I am assuming that point as x1 y1, therefore x1 is 3, y1 is minus 4, and the given circle equation is x square plus y square minus 22x minus 4y plus 25 is equals to 0. I just compare this given circle equation with the general form of circle, that is x square plus y square plus 2gx plus 2fy plus c is equals to 0. 2g is minus 2 minus 22, that implies g is equals to minus 1. 2f is equals to minus 4, that implies f is minus 2. C is equals to 25. Okay. Is it clear? Here, the equation of the normal to this circle at a point is already we have done in the previous session. Equation of normal, we have already discussed two problems. Okay, here I am taking a second problem, that is x minus x1 into y1 plus f minus y minus y1 into x1 plus g is equals to 0, which is the equation of normal to this circle at a given point. Okay, you can verify whether the formula is given or not. Okay, already we have given this formula. Therefore, the equation of normal, that is x minus x1 into y1 plus f minus half y minus y1 into x1 plus g is equals to 0. Substitute x1 as 3, y1 as minus 4. Okay, x minus x1, that is x minus 3 into y1, that is minus 4 plus f, that is minus 2. Okay, minus half y minus y1, y minus y1 here, y1 is minus 4, that is y plus 4 into x1 plus g, here x1 is 3, g is minus 11, therefore 3 minus 11, that is equals to 0. Okay, here minus 4 minus 2, that is minus 6 into x minus 3. Here 3 minus 11, that is minus 8 into minus 1, that is plus 8. Therefore 8 into y plus 4 equals to 0. Okay, minus 6 into x minus 6x plus 8 into y minus into minus plus 6 into 3 18 plus 32, that is 50. Okay, after simplification we can get the normal equation as 6x minus 8y minus 50 is equals to 0, because here x coefficient is a negative integer, therefore I am transpose all these terms into RHS. Therefore the equation of normal is 6x minus 8y minus 50 is equals to 0. Okay, here the equation of normal means here the line equation, which is of the form ax plus by plus c is equals to 0, whereas a is equals to 6, b is equals to minus 8, c is equals to minus 50. Okay. Just wait. Here all these coefficients, x coefficient is 6, y coefficient is 8, constant is 50. Here I am taking 2 as common from these terms, that is 2 into 3x, here 2 into minus 4y, 2 into minus 4y, 2 into minus 25. Okay, which is equals to 0. Just transpose 2 into RHS. Therefore, the equation of normal is 3x minus 4y minus 25 is equals to 0. Okay, here is of the form ax plus by plus c equals to 0. As you know already, which we have discussed in previous slide, the area of triangle formed by the coordinate axis is half into modulus of c square by AB, whereas A is 3, B is minus 4, C is minus 25. C square minus 25 whole square by A into B, that is 3 into minus 4. Minus 25 whole square, that is 625 by 3 into minus 4, that is minus 12. Here 625 by minus 12. Here modulus is omitting. Therefore, 12 into 2, that is 24. Therefore, area of triangle is 625 by 24. We should represent area of triangle by using square units. Okay. This is the solution to the given data. Okay. Just once again, I am recalling orally. Here, we should find the area of triangle. Okay. First, we have to find the equation of normal. Equation of normals, we can get the line equation, that is of the form ax plus by plus c equals to 0. When the line is getting, we can find the area of triangle by using this formula, that is delta equals to half into modulus of c square by ab. Okay. Just observe the question, that is normal. We should find normal at 3 comma minus 4, that is assumed as p x1 y1, and the center of the circle equation of the circle is given. Okay, after comparing general form of the circle, you may get as g is equals to minus 11, f is equals to minus 2, c is equals to 25. As you know already, we have discussed in previous session, the equation of normal is formulated as x minus x1 into y1 plus f minus of y minus y1 into x1 plus g equals to 0. Just substitute all these values, such are x1, y1, g, f, c in this equation. Okay, you can get the normal equation as 3x minus 4y minus 25 is equals to 0, which is a line, is of the form ax plus by plus c is equals to 0. Okay, already we have discussed in previous slide. Here the area of triangle formed by the line end with coordinate axis, that is half mod into c square by ab. Here c is minus 25, a is 3, b is minus 4. After simplification, you can get the area of triangle is 625 by 24 square units. Okay. This is the one of the important question which may come as 2 marks. Show that the line Lx plus my plus n equals to 0 is a normal to the circle. Then show that then the if and only if condition, that is g into L plus m into f is equals to 1. Here just observe that here the circle is equals to 0. Then Lx plus my plus n equals to 0 is a normal. But before going to drawing a normal line, we need to draw equation of tangent. This is the equation of normal. Here the equation of tangent, and this is equation of normal. Okay, as you know already, equation of normal is always passing through center of the circle, that is minus g comma minus f. Is it clear? There is no condition to the tangent. What is the point which we can find directly, but we can predict the point on the normal, that is center of the circle. Okay, or center of the circle is always lies on the normal to the circle. That means normal to the circle is always passing through center of the circle. Normal line is always passing through center of the circle. Here the s equals to 0 is a circle, and this is our tangent to the circle. This is tangent to the circle, and this is point of contact. Point of contact. Here Lx plus my plus n equals to 0 is a normal line because it is passing through center of the circle and the point of contact to the tangent line and the circle. Okay. Here given circle is assumed as general form of the circle, that is x square plus y square plus 2gx plus 2fy plus c is equals to 0. Okay, in the line Lx plus my plus n equals to 0 is given as normal to the circle. As you know already, when the circle is in standard form, so general form, center of the circle is minus g comma minus f. This is the center of the circle. And also we have already discussed when the line is given as normal, we can say that normal to the circle is always passing through the center of the circle, which is minus g comma minus f. That means center of the circle, that means this point always lies on this line. Lies on this line means the point satisfy the this line Lx plus My plus n equals to 0. That means just substitute center of the circle on this line. Okay, that is L into X. L into X, where X is minus G, that implies L into minus G, plus M into Y, that means M into minus F, or plus N is equals to 0. That is minus L into, sorry, L into minus G, that is minus LG, M into minus F, that is minus MF, plus N equals to 0. Here, just transpose all these terms into RHS. Okay, if and only if minus LG or transpose as LG, minus MG transpose as MF plus MF. Here I am not transposing EN. Okay, therefore LG plus EMF is equals to 1. Just I am transposing only these two terms. Okay, once again, when the given line Lx plus My plus n equals 0 is a normal to the circle, then show that the condition is Lg plus Mf is equals to 1. Okay, Lx plus My plus n equals 0 is normal. That means center of the circle is always lies on this line. That means just substitute instead of x minus c, instead of y minus f in the given line. That is L into x, that is L into minus c, plus M into f, that is M into y, that is minus f, plus n equals to 0. Minus Lg minus EMF plus n is equals to 0. Just transpose these two terms into RHS. That is Lg plus EMF is equals to 1. Okay, which is the required solution. Now we are going to assign a few questions. Find the area of triangle formed by the tangent at P, x1, y1 to the circle. Find the area of triangle formed by the tangent at P, formed by tangent at P to the circle. Here, suppose I am giving one circle, and I am giving point P, x1, y1. Here, I am drawing a tangent line. I am drawing a tangent line. I am drawing a tangent line to the circle. Here this is a triangle formed by both coordinate axes x and y. Okay, you need to find the area of this triangle. And next one, if x square plus y square, sorry, here it's not question. Find the area of triangle formed by the tangent at P, x1, y1 to the circle. X square plus y square is equals to a square with the coordinate axis. Then when the condition is given, x1 into y1 is not equals to 0. Okay. And next one, second question is, find the equation of tangents to the circle. X square plus y square minus 8x minus 2y plus 12 equals to 0 at the points whose ordinates are 1. Here we have already discussed in second question. Here abscissa is called x coordinates, ordinate is called y coordinate. Okay, here this is called abscissa, and this is called ordinate. Here ordinate are 1. Okay, this type of question also will discuss by the next session. Okay, I hope all are you fine. Okay, thank you one and all. Have a nice day. Sir, class is completed.